Guys, today we're moving into chapter 10. So we have to be up to chapter 10 by now, but don't ask me about it. So this is the problem. Data mining, question number 2. Compare means and standard deviations of clusters to show. Okay, this is a very strange problem, to tell you the truth. It's relatively easy, but wrong. So, yes, green. I haven't done that yet. We have to move into the problem itself. Where'd it go? It's there. There we go. Click on this link. This is the problem. Now, the problem is strange because all it's asking you to do is to see or verify the clusters after they've been created for you. And it's doing it by simply seeing how far each cluster is from the overall mean. So it's relatively straightforward Excel commands. And let's do it in Excel, and not that much. So this is the data. We have data on, I don't know, 50 colleges, and it tells you some key characteristics such as the type of college, but the numerical data involves SATs, acceptance rates, expenditures, what percentage of the classes in the top 10% of the high school, and the graduation rate. So let's move it into Excel. Amazing. And the first step is to calculate the mean and standard deviation of each of the 5 variables. So it's an equal average with the average of, oops, what happened here? The data jumped away. Oh, this group here, this is just control and arrow down. Enter, and the average is 112.63.1. The other extra decimals aren't that interesting. You might as well get the standard deviation already, equals TD. You want the sample standard deviation, so let's click on that. Let's go all the way up to these 5 numbers. So the standard deviation is a not small 62. Of course, the variance is that number squared. And let's take these 5 formulas and copy them over for the other 4 variables. And these supposedly are the averages. And you can see from the scale that these numbers seem right. That was for everybody. Then we want to do the same thing for from the cluster. The cluster is defined as Wellesley plus Wesleyan. So we'll do Wellesley. Wesleyan. And we want the mean and standard deviation. So one way of doing that is simply to take this there, copy, paste. But of course, now we're not only interested in all 50, now we just want rows 47 and 48. So here we have to modify it to C5, 47, colon, 48. Likewise, the standard deviation of those 2 numbers will be different than the whole sample. And you change this to a 47, 48. Those are the terms. And of course, we can now do that for all 5 dimensions. These are 5 variables, but really we're measuring a college in many different ways. Okay, and finally they ask us to see how far apart is all minus Wellesley, etc. And again, we're doing it on two levels, the mean and the standard deviation. And of course, that's trivial if you know Excel by now, equals all, which is C52 less C55. And the difference is 1263 minus 1270 is really wrong. C52 minus, sorry, my mistake. This is, we went C52 minus C, oh, my mistake, minus C55. So place to look. Okay, so this, take away that, is minus around 7. And they also ask you to see how far apart the standard deviations are. So 62 take away 68. So we can do C 53 take away C 56. Oh, very wrong. Oh. Minus C. Control Z undoes what you just did. C 56. C 53 minus C 56. Left out an equal sign. Computer, forgiving. And 61 take away 28 is about 34. And of course, we should copy this over. We want to see this for all of them. Now, then we're going to do the same thing for the next cluster. Well, you could do that. I'm not going to do that now. So they want you to come up with the type of the numbers for all of them. Let's show completed. You do it for, oh, I guess the other example wanted it for Wellesley, etc. I guess they pick randomly. But you pick a cluster, you get the average, you subtract it, and then they want you to make a verbal question response. Clustering shows clear differences because when you look at these differences, this is 31 away from the average, this is 88 below the average. So these clusters are different. And this is plus 36. So these two are similar, but it's different to that. On the other hand, this is 12%. This is, can't even calculate it. I should point out to you one complication. If there's only one item in the sample, you can't calculate the standard deviation of one item. Standard deviation is a measure of spread from item to item. With one item, it's doesn't make any sense to measure the spread. Even though you might argue the spread is 0, but not really. There's no spread. Doesn't make any sense. So there's no spread. That we put down n for none. But when you subtract a number minus none, again, you can't do that. So the answer again is n. So you'll see the answer n for a situation where there's only one category. Right, guys, so that's it for this example.